Welcome to our channel. Today, we'll be diving deep into a topic that is critical in the world of artificial intelligence and machine learning, building a robust AI pipeline, from data ingestion all the way to model deployment in production. Whether you're an aspiring data scientist, an experienced machine learning engineer, or just someone interested in the intricacies of AI, this video will provide you with a comprehensive overview of how to create a seamless AI pipeline. Let's start with the fundamentals. An AI pipeline is a structured and systematic approach to developing machine learning models. It involves several stages, each crucial to the success of the final model. A well-constructed pipeline ensures that data flows seamlessly from one stage to another, providing consistency and reliability in the model development process. The pipeline comprises several key phases: data ingestion, data preprocessing, feature engineering, model training, model evaluation, and finally, model deployment. Each phase has its own unique challenges and best practices, which we will explore in detail. First up is data ingestion. This is the initial stage where raw data is collected from various sources. Data can come from multiple origins such as databases, APIs, spreadsheets, or even real-time data streams. Ingesting data effectively is pivotal because the quality and type of data you gather directly influence the performance of your machine learning model. During this phase, it's important to consider the volume, variety, and velocity of the data. You need to ask yourself, is the data structured or unstructured? Will it require real-time processing, or can it be batch processed? Depending on your answers, different tools and technologies might be utilized to facilitate the ingestion process. One popular tool for data ingestion is Apache Kafka, which is designed to handle real-time data streams efficiently. It allows for the ingestion of massive amounts of data in a fault-tolerant manner. On the other hand, if you're working with smaller datasets or require scheduled batch processing, Python's Pandas library can be quite effective. Regardless of the tools you choose, the key here is to ensure that the data is ingested in a way that maintains its integrity and is ready for the next stage, data preprocessing. Once the data is ingested, the next phase is data preprocessing. This is where raw data is transformed into a clean and usable format. The preprocessing step is critical because the quality of the data directly affects the performance of your machine learning models. During this phase, you'll typically perform several tasks such as data cleaning, normalization, and transformation. Data cleaning involves removing duplicates, handling missing values, and correcting inconsistencies. Techniques such as mean imputation for missing values or using advanced methods like k-nearest neighbors, KNN, for imputation can be employed. Normalization and standardization are also significant in this stage. Normalization scales the data to a range, typically between 0 and 1, while standardization rescales the data to have a mean of 0 and a standard deviation of 1. These methods help in ensuring that no single feature dominates others due to its scale, which is particularly important in algorithms sensitive to the scale of the input data, such as k-means clustering or principal component analysis, PCA. Next, we move to feature engineering, which is often considered an art in the machine learning world. Feature engineering involves selecting, modifying, or creating new features from the existing dataset that will help improve the performance of the model. This step is crucial because the right features can significantly enhance model accuracy. Techniques in feature engineering can include feature selection, where you identify the most relevant features for the model, and feature extraction, where you create new features that can capture the underlying patterns in your data better. For example, if you're working with a dataset containing timestamps, you might create new features such as the day of the week, month, or even the hour of the day. These new features can provide additional context that may help your model make more accurate predictions. Tools like scikit-learn's select k-best for feature selection or polynomial features for creating polynomial features can be incredibly helpful in this stage. Once your data is pre-processed and you have engineered your features, it's time to move to the model training phase. This is where the magic happens. You select a machine learning algorithm based on the nature of your problem, whether it's supervised, unsupervised, or reinforcement learning, and begin training your model. This phase involves splitting your dataset into training and testing sets, typically using an 80-20 ratio. The training set is used to fit the model, while the testing set evaluates its performance on unseen data. It's important to experiment with various algorithms during model training to find the best fit for your specific use case. Popular algorithms include linear regression for continuous outcomes, decision trees for classification tasks, and neural networks for complex patterns. Moreover, hyperparameter tuning is essential at this stage to optimize the performance of your model. Techniques like grid search or random search can be employed to systematically explore different combinations of parameters. Once the model has been trained, the next step is model evaluation. This phase is critical for understanding how well your model performs and whether it meets the business requirements. Various metrics can be used depending on the type of problem at hand. For instance, accuracy, precision, recall, and F1 score are commonly used metrics for classification problems, while mean absolute error, MAE, and root mean squared error, RMSE, are typically applied in regression scenarios. Cross-validation is also a vital technique during the evaluation phase. It not only helps in validating the performance of the model but also in ensuring that it generalizes well to new, unseen data. By training and validating the model on different subsets of the data, you can get a clearer picture of how your model might perform in the real world. After evaluating and selecting the best performing model, it's time to move on to the final stage, model deployment. Deploying a model is where it transitions from an experimental stage into a production environment, making it accessible for end users or applications. This stage can often be the most challenging part, as it involves various considerations, including scalability, monitoring, and maintenance. There are several ways to deploy machine learning models, depending on the use case. You can use cloud platforms like AWS SageMaker, Google AI Platform, or Azure Machine Learning, which provide robust environments for deploying and scaling your models. Alternatively, containerization technologies like Docker can be used to package your model along with its dependencies, making it portable and easier to manage. Once deployed, it's crucial to monitor the model continuously. This involves tracking its performance metrics over time to identify any potential drifts in data or concept. Data drift occurs when the statistical properties of the input data change, which may lead to a decline in model performance. Setting up monitoring systems and alerts can help you detect issues early, allowing you to retrain or update your model as needed. Moreover, keeping a continuous feedback loop is essential for maintaining the robustness of your AI pipeline. By gathering feedback from end users and incorporating it back into your pipeline, you can iteratively improve your model, ensuring it remains effective over time. This might involve periodic retraining with new data or refining features based on user interactions. In conclusion, building a robust AI pipeline from data ingestion to model deployment in production is a multifaceted process that requires careful planning, execution, and monitoring. Each phase, data ingestion, pre-processing, feature engineering, model training, evaluation, and deployment, plays a vital role in ensuring the success of your machine learning projects. Remember, the goal is not just to create a model that performs well on training data but to develop a solution that delivers real-world value and can adapt over time. Thank you for joining us today. We hope this video has provided you with valuable insights into building an effective AI pipeline. If you found this content helpful, please give us a thumbs up, subscribe to our channel, and hit the notification bell so you never miss an update. We'd love to hear your thoughts and experiences in the comments below, especially if you have any questions or topics you'd like us to cover in future videos. Until next time, keep learning and exploring the fascinating world of AI.